All right, trying to give everybody a feel of what the temper language looks like and how we might in practice go about co-developing a standard and a reference implementation of that standard. So you're looking at VS Code here. We're using Temper's VS Code plugin. And here's a file, price.temper.md. And this is a literate standard. You can see it looks like Markdown. Now, for a lot of W3C standards work, we use BikeShed, Respec, EC Markup, one of these other formats. This is just Markdown. It's, kind of everybody knows what it looks like. So, and uh, we start off kind of describing what we're doing. We've got pros in Markdown explaining what our goals are. We want to provide support for ISO 4217, which defines currency codes for representing monies. And we continue on and we say, what does a price consist of? Well, it consists of a currency code, and we've got examples here, but then we break out into a fenced code, an unfenced code block. And so we've got an @JSON annotation, and we start defining a class. So this is kind of literate style. We're combining explanatory prose meaningful to a human with code meaningful to developers and compilers. And we go on, kind of our price class, it has a currency code and amount. And we kind of go into detail here, about nuances of the amount. The amount is an integer, but, US dollars, we've got fractional amounts. And, you know, kind of this explains how that's represented in the ISO 4217 scheme. But, classes, they've got state, they've also got behavior. So farther down, we've got things that just look like normal methods. You can probably tell from looking at this that our surface syntax for the language is very JavaScript like. It looks like TypeScript, JavaScript with types. But what we're trying to do here is appeal to a broad audience. We want the language to be very familiar to people. We're not trying to blaze new trails in syntax. And so our toString method just formats a price to a string, kind of what you would expect to see, in your locale's representation of prices. And then farther down, we've got tests. So we've got a narrative structure here. We start off with prose explaining kind of what we're doing and why. Then we get into code, which expresses the how we compute answers to the questions we need to answer. And then we say, for example, and some tests. And so here's an assert, a currency that has US dollars with an amount of 0 is going to format over here, $0.00. And this bracketed block here, it looks an awful lot like a JavaScript record. We do in fact kind of induce which type's constructor we're invoking based on kind of the structure, the factor that it has a currency code and amount, and the price type is in scope, kind of, lets us do that. So we're just picking kind of very, simple, familiar syntax for kind of, common operations. And then let's switch over and take a look at how this works. So here I fired up our temper command line tool, temper REPL-B. REPL, read eval print loop. It's just kind of an interactive code playground. And, I'm asking it to give us the code playground for the Python backend. And so it starts up CPython, and it tells us that, it's running with some translated libraries preloaded. And so I can do things like from cart demo here, the translation of the cart demo library, I'm going to import our price type. And if I look at the price type using the Python shell's kind of built-in help function, I see it's just a regular Python class. And so this, I think, is something that's important about the language. Temper works by translation to other languages. That's how it fits into their runtime. When you translate a temper class, we're not, creating any virtual machine barrier between the Python code and the Temper code. It's all Python classes and objects, you know, all the way down. And we've got our kind of documentation of the Python class from that literate document here, and you can see we've got methods for encoding to JSON, our string conversion, decoding, that kind of stuff. So let's go ahead and create a price. I'm going to say I just use normal Python to do it, and I'm going to say I want give me 1,000 yen, and it I invoked our currency formatting that uses the 4217 convention, and you can see it gives me back a string that has kind of the regular representation you would expect. And I can do some other things. If I remember the name and I can spell, and I need to go into a specific module inside our standard library. Now, third time lucky, I've got myself a place to store JSON. And so now I'm going to say, price.json adapter. We've auto-generated some utilities that help us convert prices to and from, because, we need to be able to send prices from maybe a web client to a payment processing service. And so I've got my JSON adapter. I'm going to encode to JSON. I'm going to encode that price. But first I need a place to put it. So I'm going to say JSON out equals JSON text producer. That gives me a place to store JSON. Third demo, I'll kind of get into the details of that. And if I do price.json adapter and then encode to JSON, I'm going to encode my price P to JSON out. And, that kind of puts JSON tokens on an output buffer. And then I can say JSON out to JSON string, and it gives me back kind of, well-formed JSON. And let me, Temper is a language that translates to all the other languages. So let's go and look at another language. Here I've fired up the Java backend again using Temper REPL-B, and it's given me the same kind of thing. It's told me how I can get at some get at the Java translations, just make it easy to kind of interactively explore a translation, see it from kind of a Java community user's point of view. And let me import some of the same stuff. And, price, again, we're just translating our Temper classes to regular JavaScript classes. That's how we fit into a runtime, meet, kind of programs where they are, provide high quality libraries. And I'm just going to say price P equals new price. And I'll do kind of the same thing, 1,000 yen. And it's telling me now P is bound to 1,000 yen. And if I do, it's, not just a string, I've got an instance of the class. Let me go ahead and decode that thing that I got from the other side. Over here I've got a currency string, and Java, of course, I can't mix and match string quotes. So I've got to go and escape things here. If I could remember the new Java syntax for multi-line strings, maybe it'd look nicer. I've got my string from Python. We actually do have, promises, and we have fetch implemented. So, you can build an entire web service in it, but I'm not going to try and send things between two shell sessions. But what I will do is, again, we've got our type-directed encoding. Here we've got type-directed decoding. So I am going to decode from JSON, and I'm going to do if I can remember parse JSON, and I'm going to parse that string, and I'm going to, so I'm decoding, parsing a JSON representation, and I think that's all I need to do. And I think I put my parentheses in the wrong place. And I get back now. This is, I in fact decoded it. It's an instance of the class. It's the same thing that I had before. So what did I show you? VS Code, literate style temper. We got our narrative structure is prose, followed by indented code inlined with commentary. You saw some of this commentary if you were paying close attention when I used the Python help function to kind of look at the price class. You saw some of this there. And then, our narrative structure is explain what we're doing and why. The code, indented code blocks give you the how, that's the production code, but we've also got test code. For example, when we format to a human readable string 100 Canadian dollars, because Canada has cents as well, we get this. And we've got our test cases for negative amounts there. And if I go back and look at kind of the actual test code where generating, this is the generated test code. We're not just, you can run the tests via the temper command line tool, but we also translate our tests to Java, unit tests. And of course, our Python tests go to PyUnit. So, test code tends to be pretty formulaic. And you get a level of confidence in the translation, in the Java translation, from running the JUnit test, and similarly for the other translations. So we've got this multi-tiered testing strategy. All right, that's the first demo, a literate style standards document embedding reference implementation code and actionable tests.